Hello and welcome students. This is a lecture on straight lines, and earlier to this lecture of straight lines, we have learned what is the general form of equation of a straight line. That is, we have learned that a straight line, whichever form you write its equation, its general form is going to be ax plus by plus c equal to 0. Whether you are writing equation of the line in slope point form or you are writing the equation in 2-point form or you are writing the equation in double intercept form, or you are writing it in slope intercept form, the equation of line finally they will all become this way. And that is the reason we call this form as the general form of equation of a line. We call this as general form of equation of line. What is it? You will all say it is ax plus by plus c equal to 0. We also learned that when you write the equation of a line in this form, when you write the equation of a line in general form ax plus by plus c equals to 0, then for that line the slope is minus a upon b, that is negative of x coefficient divided by y coefficient minus of a upon b. The y-intercept will be minus c upon b. The y-intercept of line is minus c upon b, and the x-intercept is minus c upon a. So now, knowing all these facts, let us go ahead and solve few more problems. Okay, so I'll be solving for you now question number 6. I'll be solving for you question number 6. See, question number 6 is find the coordinates of the foot of the perpendicular drawn from point A -2, 3 to the line 3x minus y minus 1 equals to 0. So what I will do is I'll draw a sketch here. See, this is line. I'm just drawing some rough sketch, Say this is line 3x minus y minus 1 equals to 0, the equation of the line. Now there is a point in plane, and the point is, this is the point. The point is A -2, 3. And what we have to do, we have to draw a perpendicular from this point to the line. Now, when you draw the perpendicular from the point to the line, you draw perpendicular from the point to the line, you get the foot of perpendicular. See, this is foot of perpendicular. This is M. We have to get the coordinates of this foot of perpendicular. We have to get the coordinates of this point M. Remember that this is perpendicular. This AM is perpendicular. Okay. So see, how do I get it? What I understand is, see students, what I understand is if I extend this AM, if I extend this line, so I can call this point M. See, if I extend this segment, I can call this point M as point of intersection of these two lines. Which two lines? The line which is given, this one, and this line, which is perpendicular. What is M? M is point of intersection, point of intersection of two lines. So what I will do, see, in order to get this point of intersection, which is nothing but the foot of the perpendicular, I will get the equation of two lines. That is, I will get the equation. See, this equation you already have. You already have the equation of this white line. You have to find the equation of red line. And then once I get the two equations, I will solve them simultaneously. That will get me the point of intersection. So what you have to understand is, remember, the foot of perpendicular can be considered. This foot of perpendicular here, M, can be considered as point of intersection of this line and this line. See, it is only that this line ends at M. It's only that this line ends at M. If you want, you can extend it. It is not extended. Whether you extend it or you end it here, it's going to be the point of intersection of this white line and this line. So what is M? The foot of perpendicular is nothing but the point of intersection of two lines. So see here, how do I go ahead? Now I will start with my solution. I have to get the equation of this red line, that is AM. So see here, I will write the given line is 3x minus y minus 1 equals to 0. See, this line, it is in general form. Why? Because see, right hand side is 0 and the left hand side, what I have, ax plus by plus c plus c. So see, this is general form. The given equation is in general form. The right hand side is 0 and everything is on left hand side. Ax plus by plus c. Okay. So what I will do now, I will compare this with the general form. I write here. See, I'm writing this being the first problem, but then you can write it directly also. You can directly write the value of ABC, but I'll be comparing and writing. So here I write on comparing with what? Ax plus by plus c equal to 0. So when I compare, I will get the A, B, and C. So what is A, students? A is 3. So A equals to 3. What is B? B is C. Plus By. Here you have minus Y. So B is minus 1. B is minus 1 and C is minus 1. So now I will write, therefore slope of given line equals to minus A upon B. We know that if the line is in general form, then slope is minus A upon B. That is, okay, so that is, I write equal to minus of A is 3 upon B is minus 1. So what do you get? You get minus minus plus, so you get 3. So what is slope of given line? Slope of given line is 3. You got the slope of given line as 3. Therefore, slope of given line equals to 3. Okay. Now I write, see, I write let M be the foot of perpendicular from point A. So now I want slope of AM. See, I will find out slope of AM. But what I understand, I understand that AM is perpendicular to this line. So I will write slope of AM multiplied by slope of given line, that is 3. You see this? 3 equals to -1. Why? Because AM and the given line are perpendicular to each other. You know, when two lines are perpendicular to each other, the product of their slope is -1. So what is slope of AM? So therefore, slope of AM is equal to -1 by 3. See students, I got the slope of AM. I have slope of AM and I have one point on AM. What is that? A. I have a point on AM, that is A. What I will do? I will now get the equation of AM in slope point form. So I will write therefore equation of AM in slope point form. What will that be? It will be y minus y1. Y1 is 3. You see this? Y minus y1 equals to m. Okay? Y minus y1 equals to m into x minus x1. So y minus 3 equals to m minus 1 by 3 into x minus x1. X minus of -2. So x minus of -2, it will become x plus 2. Now multiply this 3 here. So you get 3y minus 9 equals to, see 3y minus 9. This 3 will cross multiply here in the numerator. So 3y minus 9 equals to, this -1 will multiply inside, minus x minus 2. In the next step, what I will do is, see, now I'll write, now take everything off the left hand side. So you have x plus 3y. You see this x plus 3y. This x will, negative x I take on the left hand side. So x plus 3y equals to -2 plus 9. 9 I take here, minus 9. So plus 9. So x plus 3y equals to 7. This is equation number 1. That is equation of AM. Okay. What is equation of this line? What is equation of this line? The given line, 3x minus y minus 1 equals to 0. Okay. 3x minus y equals to 1. See, -1 I take on the right. So it will become +1. And this I write as equation number 2. What you have to do now? See students, you will solve these two equations simultaneously. This equation, please understand. This equation, what is that equation? That equation is x plus 3y equals to 7, which is equation of AM. Okay. And 3x minus y equals to 1. It was the given line. Okay. This is equation of given line. I will solve these two equations simultaneously. This equation and this equation, I will solve simultaneously. X plus 3y equals to 7, 3x minus y equals to 1. When you will solve, you will get the value of x, some number, y, some number. Remember, this x comma y, you will write in a bracket, x value here and y value here. These are the coordinates. This is x coordinate and y coordinate. Coordinates of point M. We have already done this thing. That's why I'm not doing it here. Okay. You will solve, you will get the coordinates of point M. And that is the foot of perpendicular. So what you will do now, you pause the video and solve for x and y. Solve for x and y. Okay. Solve these two and get x and y. That is the end of the question. And I'm sure you will do it. Pause the video, solve it, and get the answer. So students, now come to question number 7. See, in this question they say find the coordinates of the circumcenter of the triangle whose vertices are. We have to get the coordinates of circumcenter of a triangle. So see, I will first construct a rough sketch, So this is say triangle ABC. We are given the vertices. This is point A, this is point B, and here you have point C. The coordinates of A are -2, 3, B are 6, -1, and C are 4, 3. We have to get the coordinates of circumcenter of this triangle. Now see students, we all know circumcenter of a triangle is the point of intersection of perpendicular bisectors of sides of the triangle. What is circumcenter of a triangle? Circumcenter of a triangle is point of intersection of perpendicular bisectors of the sides of triangle. So see here, I will draw the perpendicular bisector, okay, of side AB, side BC, and side AC. So here, see, for drawing perpendicular bisectors, see, we are not constructing, we are just drawing a rough sketch. So say this is the midpoint of point side AB. I call this as C. Here you have midpoint of side BC. I call it as D. This I call it as E. The midpoint of AC, I call it as E, and midpoint of AB, I call this as F. Okay. So now what I do is, see, I draw the perpendicular bisectors of these sides. So here, see, I draw the perpendicular bisector of these sides. So here, see, the perpendicular bisector of BC is this. This is perpendicular bisector of BC. Okay, it is bisecting, it is passing through the midpoint, so it is bisecting, at the same time it is perpendicular. See, this is perpendicular bisector of BC. Got that? Okay, then I will draw the perpendicular bisector of AC. I draw the perpendicular bisector of AC, this. Okay, now see, these two are enough. Even if you don't draw the perpendicular bisector of AB, that is passing through F, it is okay, because that will pass through this point only. It has to pass through the same point of intersection. Okay, it has to, all the three perpendicular bisectors have to intersect at this point. And listen, students, this point here is known as the circumcenter of the triangle. This point itself is known as the circumcenter of the triangle. This point is circumcenter of triangle ABC, which is the point of intersection of perpendicular bisectors of sides of the triangle. Okay. Now, see, the third perpendicular bisector is not required. Two are enough, because the two perpendicular bisectors will define the circumcenter. They will intersect and we will. So let us call this point as P. Okay. So I will say let P be the circumcenter of triangle. Okay. I write here let P be the circumcenter of triangle ABC. Okay. Now see, students, what I do is, in order to get the coordinates of this point P, see, when I say P, look at this point. Okay. In order to get the coordinates of this point P, I will find out equation of, okay, the perpendicular bisector of BC, that is this. Let us call this as L1. Okay. And let us call this perpendicular bisector as L2. So I will, let me write there. I write let L1 and L2, let L1 and L2 be the perpendicular bisectors of sides BC and AC respectively. Okay. So see, what I will do is, I will find the equation of L1, find the equation of L2, and then I will solve those equations simultaneously. Those two equations which I will get in x and y, I will solve them simultaneously. When I will solve, I will get the value of x and y. Those x and y value, x value is x coordinate of this point of intersection, and y value is the y coordinate of point of intersection of those two lines. Okay. So see what I'm going to do. I will find out equation of L1. Now see here, how do I get the equation of L1? Always remember students, the moment you think of equation of a line, you have to think of the possible form that you can apply. So see for L1, do you have a point on L1? Do you know the coordinates of any point on L1? Right now, no, but you can always get the coordinates of point D. You can get the coordinates of this point D. Why? Because D is midpoint. This L1 is perpendicular bisector. So this D has to be midpoint of BC. Okay. So I write here referring to the diagram. See, right, referring to the diagram, this will help you solve the problem faster. Referring to diagram, you don't have to write much if you write referring to diagram. So see here, I write here by midpoint formula. By midpoint formula, see D, the coordinates of D will be, see, D, the coordinates of D, x coordinate of D is x coordinate of point B plus x coordinate of point C upon 2. So 6 plus 4 upon 2. 6 plus 4 upon 2. And y coordinate of D will be -1 plus 3 upon 2. So what is D? D is 10 by 2. 10 by 2 is 5 and -1 plus 3. 2 by 2 is 1. You understand? 5 comma 1. You got the coordinates of point D. Now what I will do is I will get the coordinates of, wait. See, after this, I got the coordinates of point D. Now I will find out slope of L1. See, now once I get this as 5 comma 1, now I understand that I got 1 point on L1. Now I need slope of L1. See, you don't know slope of L1, but you can always find slope of L1 because you can find the slope of BC. Once you know slope of BC, you can always get slope of perpendicular line L1. So see, I go ahead, I write slope of BC is equal to y2 minus y1 upon x2 minus x1. You see this? So 3 minus of minus 1, 3 minus of minus 1 BC upon 4 minus 6, 4 minus 6. So here you have 3 plus 1, 4 upon minus 2, that is equal to minus 2. So you got the slope of BC as minus 2. So what will be slope of L1? L1 is perpendicular to BC. So the product of slope of L1 and BC will be minus 1. So you can write directly the slope of L1 is the negative reciprocal of this number minus 2. So first change the sign. So it will become 2. Now take the reciprocal. So 1 by 2. You see this? Negative reciprocal of this. Negative reciprocal of this number. So you have to write negative of this and also the reciprocal. So that will be 1 by 2. So here I write, therefore slope of L1 is 1 by 2. See, you can write directly, or if you want, you can write it complete. See, you will write slope of L1 into slope of BC. Slope of BC is equal to minus 1. So therefore slope of L1 is, see, the slope of BC will go in the denominator. So minus 1 upon slope of BC, because here it is multiplied. What is that? Minus 2. So finally what you get? You get 1 by 2. So you got slope of L1 as 1 by 2. Now what, students? See, you got slope of L1. Now what you will do? You can write the equation of L1. Why? Because you have slope of L1 which is M, and you have 1 point on L1 which is D. So you will write therefore equation of L1 can be written Equation of L1 can be written in slope point form, as follows. In slope point form as follows. See, what will that be? See here. Y minus y1 equals to m into x minus x1. So that is y minus y1. What is y1? 1 equals to m, that is 1 by 2 into x minus x1. X minus x1. What is x1? 5. Now multiply this 2 here. So 2y minus 2 equals to x minus 5. Take 2y here. Minus this 2y will come here. So x minus 2y. You see this x minus 2y. Okay, take minus 5 on the other side. So this will become plus. Okay, x minus 2y equals to 3. This is equation of L1. I write it as 1. Okay, see students, you got the equation of L1. You got the equation of L1. Okay. Now what you will do, you know, students, you will find out equation of L2. You will find out equation of L2 on same line, exactly same line. What will be the first step? You will find one point on L2. What is that point on L2? Tell me. What is that point on L2? That point is E. You will find the coordinates of point E. Yes. You will find the coordinates of point E. E is midpoint of AC. AC. You see this? So as you found slope of, as you found the coordinates of D, you will find out the coordinates of E. Once you get the coordinates of E, okay, by midpoint formula, then the coordinates of E will be very simple. Minus 2 plus 4 upon 2. That is 2 upon 2, 1. 3 plus 3 upon 2. That is 6 upon 2, 3. See, you got the coordinates of E, 1, 3. Now you will get the slope of L2. How? First you will find slope of AC. Then L2 is perpendicular to AC. You will get the slope of AC. Once you got the slope of AC, you will use slope point form to get the equation of L2. And once you get equation of L2, you will write equation of L2. You will write equation of L2 as equation 2. See, this is equation of L2, which you will all find. This is equation 2. Then what? Then this equation of L2 and equation of L1, you will solve simultaneously. This equation and this equation 2, which is equation of L2. This is equation of L1. L1 equation. What you will do? This equation and this equation. These are two equations in X and Y. Linear equations in X and Y. You have solved it so many times. You know how to solve two equations. When you will solve these two equations, you will get the value of X. You will get the value of Y. Remember, these two values are nothing but the X and Y coordinate of point of intersection of L1, L2, because you solved their equation. So you will get the point of intersection of those two lines. X value is the X coordinate of point P and Y value is Y coordinate of point P. And what is point P? Circumcenter. So once you get that, then you will write therefore the coordinates of circumcenter are whatever these two values you get. You got that? So see students, you will now pause the video and you will complete the rest part on your own. What are the rest part that you have to do? You will see, you will copy up to this that I have done, and then the rest part is you will get the equation of L2. As I said, this is equation of L1. Okay, this is equation of L1. Equation of L1. You will get the equation of L2 here and then do the rest. Okay, you will pause the video. You first copy this much, then pause the video and do it. Okay, you do the same thing for question number 6 also. Yeah, look at this question, students. Question number 8. Question number 8 is, it says find the coordinates. Find the coordinates of the orthocenter of triangle whose vertices are A, B, and C. So this problem is homework for you. because in the previous exercise, I have already solved such a problem. Okay, similar problem I have already done where we found the coordinates of orthocenter. What is an orthocenter of a triangle, my dear students? We have already done. Orthocenter of a triangle is the point of intersection of altitudes of the triangle. Okay, so what you have to do, you will first say this is point, this is triangle ABC, the vertex A, the vertex B, the vertex C. Now from these three, you will draw the altitudes and the point where the altitudes are going to intersect each other. See, from point A, you draw the perpendicular. Then from point C, you draw the perpendicular. And remember, these are perpendicular. They are not medians. Okay, so they may not meet the midpoint of opposite side. Okay, these are not medians. So now this point is point of intersection of these altitudes, and this point is orthocenter denoted by H. So what you'll have to do, say this is this, you call this as AP, this altitude, you call this as BQ, this is CR. You understand? And then you have to get the equation, or don't have to solve for all three altitudes, solve any two, because you have to solve the equation of those two altitudes to get the point of intersection of altitudes, which is going to be H. And how to get the equation of altitude, that I've already taught you. Okay, you will solve this problem on your own. This is homework for you. You must solve this very interesting question. Okay, look at this question number 9. In question number 9 is, we have to show that the given three lines, see here, one line 3x minus 4y plus 5 equals to 0, second line 7x minus 8y plus 5 equals to 0, and the third line 4x plus 5y minus 45 equals to 0. We have to show that these three lines are concurrent lines. They are concurrent. Now understand what is meaning of concurrent. See students, you all know that any two lines which are not parallel, they will always intersect each other at one point. Okay, we all know that any two lines, say L1 and L2, they will always intersect each other at one point. So there is nothing big in this. There is nothing great in this. Always two lines always intersect at one point. But if there is a third line and the third line also passes through the same point, it's a big thing. It's a big thing, because see, the third line could have passed this way. You could have had the third line this way, this way. It could have been any way. You understand? But it is passing through the same point of intersection of L1 and L2. Now, when three lines pass through one point, then these three lines, L1, L2, and L3, they will be called concurrent lines. They'll be called concurrent lines. Yes. Remember, students, concurrent lines are those lines which pass through one single point. They all pass through one single point. Okay. Think this point is P. Let us call this point as P. So I can say that point P lies on, then I can say that point P lies on L1, L2, and L3. It lies on all the three lines. It lies on all the three lines. Okay. Remember, and if it is lying on all the three lines, then by the concept of locus, when a point lies on a locus, the coordinates of the point will satisfy the equation of that locus. Point P, the coordinates of point P, x and y, this x and y will satisfy equation of L1. This x coordinate and y coordinate value will satisfy the equation of L2, and it will also satisfy the equation of L3. Okay, this is what is meaning of concurrent lines. Okay, let us come to the question once again. I have explained you what are concurrent lines. Okay, three lines, when they intersect each other at one single point, we call those lines as concurrent lines. So see what they say. They say that show that they're asking us show that the lines, these three lines are concurrent. You know the method what I will adopt. I will I will use a simple method. What I want to prove? I want to prove that this line. I want to prove that this line, and this line. The three lines are passing through one single point. One single point. That is what I want to prove. Or in other words, I have to prove that, the point of intersection of this line and this line, point of intersection of this line and this line is also the point of intersection of this line, this line, this line, this line, whatever. You understand? They all have the same point of intersection. So see students, how do I solve it? Very interesting, very easy question, but then very important also. So see here, I will write the given lines are 3x minus 4y equals to minus 5, 1. Okay, I took this 5 on the left, so minus 5. This is my L1. Okay, this is line L1. I call this as L1 line. Okay, see three lines. Here I am drawing three lines. That means corresponds to L1 corresponds to this equation. This is equation of line L1. Then L2. L2 is I will write 7x minus 8y equals to minus 5. And L3 is 4x plus 5y equals to 45. Third equation. Okay. See students, what I will do. I will solve these two equations simultaneously, L1 and L2. I will solve equation of L1 and L2 simultaneously. Why? See, if I solve these two equations simultaneously, I will get the point of intersection of L1 and L2. Yes, I will get the point of intersection of L1 and L2. Okay, let me do that much first. See here. So I write multiplying, I write here multiplying equation 1 by 2. Equation 1 by number 2. This is number 2. Okay. So see here, when I do this, what do I get? I get here 6x minus 8y equals to minus 10. I multiply throughout by 2. Okay. This is my 1a. 1a means it is the same equation but modified. So 1a. And what was second equation? See, second equation was I'm solving L1 and L2. So what is L2? 7x minus 8y equals to minus 5. This is equation number 2. You know, subtract second equation. So when you subtract, see the sign will change. Negative. This is plus. So it will become minus 7x. This is minus, it will plus and plus. Why? Because we are subtracting. Now what will happen? See this minus 8y plus 8y, this will become 0. And you will get 6x minus 7x is minus x. You get 6x minus 7x is minus x equals to minus 10 plus 5 is minus 5. So you got x as 5. Okay. Now this x you substitute in any one of the equation, 1 or 2, whatever. So I write here using x equals to 5 in 1. So when you do that, so you get 3 into 5 minus 4y is minus 5. So you get 15 plus 5, minus 5 I shift here. 15 plus 5 equals to 4y. I shifted 4y on the other side. So what am I getting? See, I'll get here. Therefore, 4y equals to 20. So y equals to 5. Okay, y is also 5. So we got the, therefore, I will write therefore point, I'm sorry. Therefore, lines L1 and L2 intersect. See, these two lines intersect each other at P5, 5. You know, see, this is x coordinate is 5, y coordinate is 5. So 5, 5. 5, 5 is the point of intersection of lines L1 and L2. So if this is L1 and this is L2, if this is L1 and L2, this is L2, L1. Remember, L1 and L2, they intersect each other where? At point 5, 5. Okay, I got the intersection. I got the point of intersection of L1 and L2. I got the point of intersection of L1 and L2. Now the only question is, they are asking that show that the three lines are concurrent. Okay, so I have got the point of intersection of these two lines. I just want to show that this line also passes through same point. If I'm able to prove that this line is also passing through the same point, my job is done. So see here, how do I do it? I will write put x equals to 5. See this x coordinate is 5. So I write put x equals to 5 and y equals to 5, because y coordinate is also 5, in equation of L3. See, in equation of L3. Why I'm doing that? See, students, if this line also passes through this point, then the coordinates of this point will satisfy the equation of L3. That is what I'm checking. Here. Okay. So I write put x equals to 5 and y equals to 5 in equation of L3. So just put it. So 4 into 5 plus 5 into 5, y is also 5, equals to 45. Check 20. I'm sorry, this is 5, not y. Y is also 5. So you have, so here what you have, 4 5s are 20, 5 5s are 25, equals to 45. And see, 20 plus 45 is 45. So what am I getting? Here? I'm getting 45 equals to 45, which is true. So here I write, therefore, 45 equals to 45. You see this? I got left hand side also 45. So I write which is true. It means, therefore, coordinates of P satisfy equation of L3. Coordinates of P satisfy equation of L3. Therefore, lines L1, L2, and L3 pass through one common point. These three lines pass through one common point. Therefore, lines L1, L2, and L3 are concurrent lines. They are concurrent lines. Okay. And in the question, they had also asked us, if you see the question, they had also asked us, you can check here, they're asking you find their point of concurrence, that is the point of intersection. So what is the point of concurrence? You will say the point of concurrence is 5, 5 that we already found. You see this 5, 5. I will write point of concurrence means the point through which they all are passing. Okay, the point at which they all are meeting, those three lines are meeting. I will write the coordinates of point of concurrence are 5, comma 5. I hope you all followed it. Please copy this and watch this once again. Learn it properly. Okay, students, now see this question number 10. This is also very interesting question. It says, the question is, find the equation of the line whose x-intercept is 3 and which is perpendicular to the line 3x minus y plus 23 equals to 0. Okay. So, the required line, always remember, required line. Learn this. Required line. What is meaning of required line? The line whose equation you have to find. They're saying, what are they saying? They're saying find the equation of the line. So this line whose equation you have to find is a required line. Then the next we will use the word given line. Okay. What is given line? The line which is given. See here, this is given line. Okay. So what are they saying? They are saying they are asking you to get the equation of a line which has x-intercept as 3. The line, the required line has x-intercept 3 and the required line is perpendicular to this given line. Okay, this given line. Okay, so see here, how do I go ahead? I will start writing. The diagram is not necessary. Okay, it is not necessary. We should learn to solve sometimes, even without the diagram. So I will write here, let the required line be L1. Okay, now I will call it L1 everywhere, wherever I want to write required line. Okay, and the given line is this. And let the given line be L2. So what is L2? Therefore, equation of L2 is, see, I know the equation of L2. Therefore, equation of L2 is 3x minus y plus 23 equals to 0. See, they give us the equation of L2 in general form. Ax plus by plus equals to 0. Now, I can get the slope. Therefore, slope of L2, which I can call it as M2, is minus a upon b. Whenever a line is given in general form, ax plus by plus c equals to 0, ax plus by plus c equals to 0, the slope is minus a upon b, minus of x coefficient upon y coefficient. Now you can ask me, sir, this time you are not comparing, you did not write the value of a, you did not write the value of b and c. See, students, you don't have to do it every time. But if you prefer to write it that way, I have no objection. You can go ahead and you can write comparing with ax plus by plus equals to 0, as I have done in the earlier question here. Okay, but I'm not doing it. So here M2 slope is M2, L2 slope, I assumed it as M2. So minus of A, what is A? 3. Okay, minus of A. See, this is minus of A upon B. So this minus, and then I write A value. A is 3. And what is B? B is minus 1. B is minus 1. See, the coefficient of Y is minus 1. So what it becomes? M2 is 3. Okay. Now see here, students, I am given that required line is perpendicular to given line. What am I given? I am given that required line is perpendicular to given line. So if the required line is perpendicular to given line, what will happen? The slope of required line and slope of given line, when we will multiply, we will get -1. We will get -1. Okay. So see here, I write, since required line is perpendicular to given line, therefore M1, slope of L1, required line is M1. So M1 into M2 is -1. Yes, when the two lines are perpendicular, the product of their slope is -1. So what will be M1? M1 is equal to -1 upon M2. M2 is 3, so it is -1 upon 3. I got M1. Slope of required line is M1. So see, students, you got slope of the required line. You got L1. You got L1 slope. You got the slope of required line. Now what you need? you need 1 point on the line. So, see, you got slope of L1. I will write here. Therefore, slope of required line equals to M1 equals to minus 1 by 3. Tell me, just by having the slope, can you get the equation of a line? Not possible. Not possible. Slope of required line is M1, which is minus 1 by 3. Only by having the slope, you cannot get the equation. What you need? You need 1 point on the required line. How will you get 1 point? See, my dear students, they are saying that x-intercept of the line is 3. Find the equation of the line whose x-intercept is 3. You know, if x-intercept is 3, what does it mean? What does it mean? It means the line is cutting x-axis. The line is cutting x-axis at 3. This is your x-axis, this is y-axis, and the line is cutting x-axis at 3 like this. Okay, what does it mean? This point is on the line. See, if this is the line, required line L1, then it is cutting the x-axis at 3. So this point is on the line, and if this point is on the line, you know the coordinates of this point. This is 3 comma 0. This is 3 comma 0 because x-intercept is 3. So the y coordinate of that point will be 0 because that point is on x-axis. You know the definition of x-intercept. Okay. Now here, you know, students, I will write a note for you. Okay. And that note you will remember now onwards. See, let me write a note for you. Very important note I shall write for you. See, let me write that note here. Okay. If x-intercept of a line is a, if x-intercept of a line is a, what is a? A is some number, some number. If x-intercept of a line is a, then point a comma 0, lies on the line. You can check. The same thing is happening here. The x-intercept of the line L1 is 3. The x-intercept is 3. So point 3 comma 0 is on the line. It lies on the line. So this is now permanent. You should now remember this note forever. If you know x-intercept of a line, then that number comma 0 is a point on the line. And same thing is true even for y-intercept. Okay. So let me write one more note. One more note I will write here. Let me write one more note here. See. If y-intercept of a line is b, if y-intercept of a line is b, then point 0 comma b, then point 0 b. Why 0 b? Why x coordinate 0? Because if it is y-intercept, it means the point lies on y-axis, so the x coordinate will be 0. Then point 0 comma b lies on the line. It lies on the line. Okay. So, but here you will please write these two notes in your notebook. Please write these two notes somewhere in the notebook and mark it very important, very, very, very important. Okay. I am removing it. So here, see here. What I'm given the x-intercept of the required line. Clearly said that x-intercept is 3. So I will write here. I will write since I'll write here since x-intercept of required line, that is L1, sorry, L1. Since x-intercept of L1 is 3, therefore, 3 comma 0 is a point on L1. Now see here, students, you have a point on L1, required line, and you have slope of L1. Can you get the equation of L1? Yes, you can solve the equation of L1 in slope point form. You will write therefore, equation of line L1 can be given in slope point form. It can be given in slope point form as follows. Can be given in slope point form as follows. How? See here. You will write y minus y1 equals to m into x minus x1. Y minus y1. What is y1 here? See here. Y1 means the y coordinate of the point on the line, that is 0. So what do you have? You have y minus 0 equals to m. M is minus 1 by 3. Minus 1 by 3 into x minus 3. Multiply this 3 here. So y minus 0 is y, this thing is y, so you get 3y equals to minus x plus 3. This minus 1 is multiplied inside the bracket here, in this bracket. So what do you get? You get therefore x plus 3y, you get your x plus 3y, minus 3, shifting everything here, equals to 0, is the equation of required line. Is the equation, this is the equation of required line. I hope you all followed it. Thank you. Please do this.